Okay, so here we're looking at simplifying radicals. Now remember that radicals are referring to the actual sign for the square root or third root or any sign here that's used to find any type of root. So we're simplifying the square root of 66, and we're simplifying it. We're not solving it because we can't find a simple rational number that's squared and will get you 66. Now your biggest friend here in this whole process is going to be prime factorization. And you might want to go back and review that, but prime factorization really is the key to this process, and we'll cover how to do that here. So what do? Well, the square root of 66, you're trying to kind of split it into factors and then take the square roots of the factors until you can break this thing down a little bit. For example, let's look at the square root of 8. The square root of 8, right, equals what? The square root of, well, 4 times 2 is 8, same thing. And a basic law of roots and powers here is that we can then draw this apart. So the square root of 4 times the square root of 2, you take the square root of both pieces in here, is still the same exact thing. And here, the square root of 4 is just 2. So 2 times the square root of 2, the square root of 2 can't be broken down any further, is the simplified version of the square root of 8. Now, prime factorization is our friend here, so we can really re-look at that. The square root of 8, if we take the prime factorization of that, well, we can say, I know 8 equals 2 times 4, and 4 equals 2 times 2. And here, right, this means that 2 times 2 times 2 is 8. So we break this thing down to its prime factors. It's the prime factorization. So we have 2 times 2 times 2. And what this, allows you to do is say, oh, well, that means that we have a pair of 2's times a 2, and it gives us 8. With square roots, every pair, right, will be a perfect square. So here, the square root of 2 times 2 is just going to be 2. And the little 2 that's left over here is still in the square root. So here we can break apart the square root of a number by its prime factorization. And with the square root, you're looking for pairs of numbers, and every time you get a pair, right, you get a perfect square, because anything multiplied by itself, any pair of numbers that's equal, will be a perfect square. So here with 66, that's our approach as well. So you can pick any 2 factors to begin with. I'll pick 11 times 6, so that's what comes to mind for me. And then 11's prime, it's done. We can't break it down anymore, so we leave it alone. But 6, remember you're finding factors here, not numbers to add, but factors. 6 can be thought of as what? Well, 2 times 3. I'm not going to use 6 times 1, that's not really going to help me. Now here we have it. We have 2 times 3 times 11. Well, here there are no pairs of numbers. In other words, there's nothing that we can break down. So here, when there's nothing you can break down, what do you put in the answer space right here? Well, in the first place, you can put a 1. So 1 is always there. And inside, you just leave the 66. Now, here, if you have an issue with that, just leave the first space blank. All right, that'll work. That should work as well. But let's just check. So here I'm going to enter in 1 and then 66, and great. But what happens if I enter 0, or what happens if I leave it blank? All right, it seems to accept it. Now in the next one here, simplify 45. Let's just do that real quick. I'll clear this off. So now we're looking at the square root of 45. Well, this is where prime factorization works really nicely. 45 is what? Well, we can think of it with any 2 factors, but I'm going to use 9 times 5. 5 is prime and can't be broken down, but 9 can, into 3 times 3. And there's our pair. We want that pair, right? So square root of 45 is the square root of 3 times 3 times 5. What's the square root of 3 times 3? Well, that's just 3. So we can think of the square root of 3 times 3 times the square root of 5. This is going to help us. The square root of 3 times 3 is just 3. Times the square root of 5 is the square root of 5. So here your answer is going to be 3, right? 3 radical 5. And if that's not, helping you, think of it this way. This step, when you have the square root of 3 times 3, that's the square root of 9. And the square root of 9 is going to get you 3 right here. So the point is, when you use prime factorization, it's really important to break them down into these prime factors down here, write it out, and then break it down. You can always reconstruct it, like here, 3 times 3, you can think of it, you can go back and again think of that as 9. But if you don't do this, there are lots of examples where you can miss perfect squares. So break it down those prime factors and you'll just nail all these problems. Thanks.